The spooky sounds of space. Since the 1950s, probes sent into space have been sending back data that reveal eerie sounds from the vastness of the galaxy. There is no sound in space. Sound is produced by the vibration of molecules. Anytime something moves, it causes a corresponding vibration in its medium, whether water or air, which, in turn, vibrates the eardrum of any nearby listeners and is perceived as sound. In the vacuum of space, there is no air, nothing for vibrations to travel through, which means there is no way for those vibrations to reach your ears. In space, truly, no one can hear you scream. That does not mean that we have no audio recordings of what's out there, quite the contrary. But they are not originally recorded as audio. Rather, they are changes in energy, picked up by instruments on various probes, plasma vibrations, electromagnetic disturbances, radio waves, and the interactions of charged particles. These recordings can then be converted into sounds, much like the terrestrial radio signals, also a kind of electromagnetic radiation, we create to communicate and entertain. Unlike tuning into your favorite radio program, though, the sounds of space are a whole lot stranger. The howls and whistles of radiation, lightning, plasma waves, coronal mass ejections, solar winds. Interestingly, some of them sound not dissimilar to the sound effects of The Forbidden Planet, the first film to ever have an entirely electronic score, composed by electronic music pioneers Lewis and B.B. Barron. Lewis built the electronic circuits and recorded the sounds, while B.B. was the one to compose the music, sifting through hours of tape to put the sounds together. And yet neither B.B. nor Lewis had ever heard any space recordings. Forbidden Planet was released in 1956, a year before the launch of Sputnik 1, the first ever artificial craft sent into space. Since then, a number of probes have sent back spectrograph recordings, but up until that point, the only sounds from space we had been able to receive from Earth had been static pops and hisses. I just knew instinctively that that's what it is to sound like when you were traveling through space, B.B. said of the soundtrack in a 1992 interview. If our circuits started doing things that even remotely resembled existing instruments, we just tossed it out. We didn't even want to sound like any existing instrument, it was totally out of our realm. The first person to hear audio from deep space was physicist and radio engineer Karl Guth Jansky, who first identified radio waves from space in 1931. He had built a giant antenna, nicknamed Jansky's merry-go-round because it was mounted on a giant turntable, designed to receive radio signals at a frequency of 2.05 MHz, a wavelength of 14.5 meters. After several months of recording in all directions, Jansky had identified three types of static: nearby thunderstorms, distant thunderstorms, and a faint but steady hiss of unknown origin. After tracking it carefully, he realized that was occurring not every 24 hours, but every 23 hours and 56 minutes, the length of a sidereal day, the time it takes for the stars to move around the sky. And its source was not our solar system, rather, it was coming straight from the heart of the Milky Way galaxy, the very first audio heard from outer space, earning Jansky the title of Father of Radio Astronomy. To this day, astronomers still use his name. The unit of measurement for the strength of radio waves from space is known as a Jansky. The crater Jansky on the Moon is named after him, and high-frequency static noise from deep space is known as Jansky noise. Both the equipment we use, including space probes and radio telescopes, and our knowledge have advanced significantly since that time. When Russia launched Sputnik 1 in 1957, it was equipped with 4 antennas between 2.4 and 2.9 meters long. These were used to obtain data about the density of the upper layers of the Earth's atmosphere and the propagation of radio signals in the Earth's ionosphere. In 1958, the U.S. launched Explorer 1, equipped with various scientific instrumentation, including a crystal transducer and solid-state amplifier used to detect cosmic dust impacts on the skin of the satellite, and, in 1962, Canada launched Allout 1 to act as an ionospheric sounder in order to study the effect of the ionosphere on radio communications. All of these craft were satellites intended only for Earth orbit. Things got a little more interesting with space probes, craft intended to leave Earth orbit and explore space proper. Some of the finest audio recordings of space and planetary phenomena have come from probes such as Voyager 1, launched in 1977, which is still operational and became the first human-made object to leave the solar system on August 25, 2012. Voyager 2, also launched in 1977 and the only spacecraft to have visited Uranus and Neptune. Cassini, launched in 1997 to study Saturn. Galileo, launched in 1989 to study Jupiter, and the Polar spacecraft, which was launched in 1996 to perform his research a little closer to home, planet Earth. Here are some of our favorite sounds from our solar system and beyond. This is the sound of GRS 1915+105, a binary star system consisting of a regular star and a black hole. The X-ray data of the black hole throwing off its accretion disk, recorded by the Rossi X-ray Timing Explorer satellite launched in 1995, was translated into audio by MIT's Edward Morgan. The low-frequency static is the background Z-ray, the pulsations, like a heartbeat, are the black hole's infrared jets, and the high-pitched whistling sounds are the quasi-periodic oscillations of escaping X-rays. The deepest sound ever captured from space came from a black hole, more specifically, a supermassive black hole located 250 million light-years away in the Perseus cluster. The sound is 57 octaves below middle C, a million billion times deeper than the limits of human hearing to, even could we hear it in space, and has been characterized as a B-flat. When Voyager 1 reached interstellar space, it recorded these readings. They are electron plasma oscillations, created by our very own Sun, which blasted clouds of particles and energy in Voyager's general direction. When they reached Voyager, they vibrated the plasma, ionized gas, surrounding the craft, which was in turn picked up by Voyager 1's plasma wave instrument. When the scientists analyzed the data, they discovered that the frequency of the oscillations was 40 times greater than if Voyager 1 had still been inside the heliosphere, the Sun's supersonic atmosphere. The two events shown in this video, the first from October-November 2012 and the second from April-May 2013, indicate an increasing frequency, which in turn suggests that the density of electrons is increasing the farther Voyager 1 moves from the solar system. The sound of Saturn is most like something straight out of science fiction. Recorded by Cassini in April 2002 using its radio and plasma wave science instrument, these sounds represent the ring planet's unusually intense radio emissions, linked to the auroras near its poles. The complex radio spectrum bears a close resemblance to the radio emissions from Earth's auroras. Earth itself makes some beautiful sounds. This particular sound is known as the auroral chorus, and is produced in the Van Allen radiation belts by electrons spiraling along the planet's magnetic field lines. This recording comes from data collected by the Electric and Magnetic Field Instrument Suite and Integrated Science Instrumentation on NASA's Radiation Belt Storm probes, which were launched into orbit in August 2012. This one sounds a bit like the slowdown sound, an iceberg scraping the sea floor, and this one a little like a theremin.